Dear students, I welcome you all to this microprocessor tutorial series. In this video, we will learn about the stack input output and machine control group instructions. So first of all, we have to understand that we have to use some stack concept in the case of various instructions given in this table. So in this table, I have shown various parameters or various status flags, T states, number of T states required. Then we have the addressing modes. So this is the machine cycle, addressing mode, flags, T states. These are the various factors we will discuss in this video. So if you are not yet subscribed to my channel, please subscribe and hit the bell icon for future video upload notification. Here we have total of 14 number of instructions. We will see one by one. So first of all, let us see this in port address. So this in instruction, what is the meaning? So whatever be the data available that is given in the instruction, that will be moved to the accumulator. Okay, so here we have this port address. This port address will be moved to the accumulator. So here you have to keep in mind that in the case of 8085 microprocessor, the port address is of 8-bit. The memory address is of 16-bit because the memory bus data width is 16-bit memory bus. We already know that the accumulator content is of 8-bit and the port address is of 8-bit. So we can directly data available at the port will be transferred to the accumulator. So whatever be the port address given in the instruction, suppose we have in 01. In 01 means this 01 is the port address. So whatever be the port address given, the data available in that port will be moved into the accumulator. So whatever be the content available in the port, that will be moved into the accumulator. So after execution of this in instruction, the address of the port is specified. So this is the 01 is the port address, but this is not the data. So whatever data available in that port address, that means whatever data available in that port, that will be moved into the accumulator. So here we can write, so whatever be available data in the port, that will be moved into the accumulator, or that will be copied into the accumulator content. Okay, so this is our first instruction. Now this instruction requires 3 machine cycles. We have 10 number of T states. None of the flags are disturbed, and this is a direct addressing mode. Why direct addressing mode? Because we have the address of the port given in the instruction. We have already seen about the addressing modes, how they work, what is the function of different addressing mode. So how different addressing modes are classified and which instruction falls under which addressing mode, then only you can understand. I hope you will go to that video and you will watch thoroughly, and then you will understand about the addressing modes. Now let us go to our second instruction. This second instruction is also similar, but here the direction is opposite. Okay, so here in this case, out means we have to give some output. So whatever be the content of the accumulator, that will be copied to the specified port address. Okay, let me write down here. So whatever be the content of the accumulator, that will be written into the port given by the address in the instruction. Okay, this was the second instruction. Here also the process is similar. We have 3 number of machine cycles. This is the direct addressing mode. We have none of the flags are disturbed, and we have 10 number of T states required for this instruction. Next we have push RP. So whenever we have RP, small r, small p, RP represents here a register pair, but there is no RP called register pair in 8085. We have suppose BC, DE, HL, these are the register pairs. Okay, so we will be having some register pair that will be given in the instruction, and whatever be the content of that register pair, that will be moved into the stack. So what is the concept of this stack? You have to understand. So here we will be having, suppose, let me show you here. Suppose we have a stack here. A stack means we have different addresses and data are stored in that stack. Suppose we have data up to here. So here we have, suppose, data field. Okay, so in this stack, let me write down here, this is a stack. So in this stack, what we can say that this data is supposed fill up to here, this point. So in the case of stack, we'll be having some addresses. Each of these memory addresses, suppose let me write down here, suppose we have the addresses 2000, 2001, 2002, 2003, 2004, 2005, 2006. Okay, so these are the suppose addresses. Now when the stack is filled up to suppose this point, what will happen? The stack pointer will be pointing at this address. SP means here stack pointer. So this stack pointer will always point to the top of the stack, because we know that in the case of stack we have last in first out. That is, whatever be the data that is last input, that will be output first, that will be taken out first. So when we have this stack pointer pointing at this address, and when we have this push instruction, push RP means register pair. Register pair will hold 16-bit data. So in the case of register pair holding 16-bit of data, whatever be the higher order register pair data, higher order 8 bits, that will be moved into the stack pointer -1. That is the previous address. The stack pointer was pointing at this 2003 address, so we have to go to this address. This is SP -1. So this is the stack pointer -1. Okay, so whatever be the content of the higher order register pair bits, okay, that means 8-bit in higher order byte, so that will be moved into the stack pointer -1. So let me write down here stack pointer -1 at this address the register pair higher order data. RH here means register pair higher order data. Let me show you one example, give you one example. Suppose we have 00001010101001. Suppose this is the 16-bit data. So this higher order 8 bits, this is RH, and this lower order 8 bits RL. This will be RL. Okay, that means register pair higher order 8 bits RH and lower order RL. So this higher order 8 bits will be stored here. So at this point the register pair higher order 8 bits will be stored, and at the previous address, now this will be SP -2. Okay, so at this point the lower order 8 bits will be stored. So RL, that means the register pair lower order 8 bits will be stored at SP -2. Okay, at this point the lower order register pair data will be stored. Okay, so in this way this instruction will be executed. Now we have filled the data up to here, because now we have stored the register pair content in the stack. So therefore now we have to modify this with the stack pointer. Now the stack pointer must indicate or must point to this address. Okay, now the stack pointer content will be 2001. Previously it was 2003 before execution of the operation. Now the stack pointer we have to modify. So how we will modify? The stack pointer will be modified with the stack pointer -2. So this will be now the content of the stack pointer. Okay, now the stack pointer will point at this address. Now we have understood about the push RP. I am not going to explain for all the instructions. I have just shown for one example. Okay, this is the instruction push RP. That means push the content of the register pair, whatever be the register pair. Suppose it may be BC, it may be DE, or it may be sometimes HL pair also. So that will be pushed into the stack. So how the data will be manipulated into the stack, we have written here. So in this instruction we can directly write down these points. So these are the functions that will be executed by this given instruction. Okay, so this instruction will perform, these are the functions. Now let us go to our next instruction. So in the next instruction we have push PSW. Here PSW stands for program status word. Here we have to keep in mind that the content of the accumulator will be pushed into the stack. The content of the status flags are also pushed into the stack. What we understand by this? Pushed into the stack means, well, here we have two operations. One is the program of the accumulator will be pushed into the stack. So firstly, what will happen? We have to store the accumulator content into the stack pointer. Then in the previous address, so let me write down here, then we will understand. So what will be the first function in the case of PSW? So what will happen? First of all, the content of the accumulator will be stored into the SP-1. So we have already seen why we have stored here. Next, what will happen? The program status word 8-bit data. Therefore, PSW, this will be written into the SP-2. Okay, so this will be modified. Again, what we have to do? Again, we have to modify the stack pointer with the SP-2. So SP-2 will be now written into the SP. That means the stack pointer value will be modified with SP-2. So these are the 3 steps that are performed for push PSW. So what is the function of the push PSW? So push PSW, first of all, the content of the accumulator will be pushed into the stack, and then the content of the status flags are also pushed into the stack. Okay, so program status word means, that means that whatever be the status flag, we have already seen about the various status flags. Okay, so status flags are actually 8-bit data that will be also modified, that will be also pushed into the stack. So in this case also we have 12 number of T-states. In the previous case also we have 12 number of T-states and 3 number of machine cycles for each operation. In both the case we have register indirect or register addressing mode. Okay, none of the flags are modified after going through this instruction. And next we have the pop RP. So pop RP means, push RP means we have to send the data into the stack, and pop means from the stack into the register pair. Okay, so RP here also means the register pair. So here also let me write down here pop RP. So what is the meaning of pop? Pop means we have to take something from the stack. So whatever be the stack pointer content, previously stack pointer content was modified with stack pointer -2. So now whatever be the stack pointer content, that will be stored into the register pair lower order address. We have already seen that the register pair is a 16-bit. So register pair can hold 16-bit of data. Therefore, the lower order register pair data will be modified with the stack pointer content. Here we have to use 2 number of square bracket because we want to access the data. So stack pointer, when we write SP within a square bracket, this means a address. When we give 2 number of square bracket, that means this is the data available in that address. So whatever be the data available in that stack pointer memory address, that will be loaded into the RL. Next, what we have to do, stack pointer +1, that will be moved into the higher order address or higher order 8 bits of the register pair. Now we have pop, that means we have taken from the stack to the register pair. Now the stack pointer address must be modified with stack pointer +2. That means stack pointer +2 will be written into the stack pointer. Now the stack pointer will point to the lower order address. Okay, so we have pop this one data, we have pop this one data. Now the stack pointer will again point here because SP-2 +2 means SP. Okay, so after pop instruction, again it will go to the previous stack pointer value. Okay, so this is the operation of the pop RP instruction. Okay, so we have learned about the pop RP instruction. Here we need 10 number of T-states, 3 number of machine cycle, and this is register and register indirect addressing mode. None of the flags are modified. Next we have pop PSW. The function is similar with the push PSW, but here the content will be moved from the stack pointer to the program status word as well as the accumulator. So in the previous case we have seen push PSW. So now we will see pop PSW. So whenever we have pop PSW, whatever be the function, let me write down here. So previously we have stored the accumulator content into the stack pointer -1. So first of all, whatever be the stack pointer content, this means the address, and if we use 2 number of square bracket, this means the stack pointer address holding data. We are now representing the data that will be moved into the program status word. Okay, and whatever be the content of the SP+1, that will be moved into the accumulator. Okay, so this is the second operation. Again we have to modify, because we have previously SP-2, now we have to modify the stack pointer with SP+2. and now the SP, that is the stack pointer, will be modified with SP plus 2. Okay, so this is the meaning of this pop PSW instruction. So for this instruction we need 10 number of T states. It is the register indirect addressing mode. Number of machine cycles are required, and none of the flags are disturbed here. Next we have the halt instruction, HLT. So what is the meaning of this halt instruction? When this instruction is executed, the program execution process is now stopped. The microprocessor remains in the halt state. Halt state means in the stop state. Halt means we can say it to be a stop. That means now the processor will stop the execution of instruction. So what will be the function? It will be the halt operation. That is the stop operation. So when the processor is in halt state, an interrupt or reset is required to exit from the halt state. In this case, we need 1 number of machine cycle, 5 number of stage states. None of the flags are modified, and there is no manipulation of data. There is no transfer of data. There is no copy or manipulation of data. Therefore, addressing mode is not mentioned here. Okay, next we have XTHL. So here in this case, we have to exchange the stack top with the HL pair. So whatever be the content of the stack top, see, let me show you here with another stack. Okay, so let me use same numbering here, 2000. This is the address, 2001, 2002, 2003, 2004, 2005. Suppose this is the stack. Okay, so now suppose the stack pointer is pointing at this address before going to this instruction. So what will happen? The stack pointer content will be loaded into the HL pair. So let me write down here the instruction XTHL. What is the meaning of this XTHL instruction? The content of the register L will be exchanged with the byte at the stack top. The content of the H register will be exchanged with the byte below the stack top. That means whatever be the content here, that will be written into the L of the register pair. That means, let me write down here, the L of the register pair, HL pair, that will be written with the content of the stack pointer. Therefore, when we say content of the stack pointer is actually a address, but the content contained in that address is given by this 2 number of square bracket. So whatever be the data available in that address given by the stack pointer, that will be moved into the L register of the HL pair. Stack pointer plus 1. This data will be given into the H, that is the higher order 8 bits of the HL pair. Okay, this is the function of the XTHL. That is the exchange the stack top with the HL pair. Okay, this instruction requires 16 number of T states, 5 number of machine cycles. This is the register indirect addressing mode, because we have the data manipulation here, and data is given in the instruction, or register is given in the instruction that is holding the data. Therefore, this is a register indirect addressing mode, and we need 5 number of machine cycles, 16 number of T states. Okay, next we have SPHL. So what is the meaning of this SPHL? We have to move the content of the HL pair into the stack pointer. Okay, so whatever be the content of the HL pair, let me write down here, SPHL. So what is the meaning? Whatever be the content of the HL pair, that will be moved into the stack pointer. Okay, that means whatever be the data, 16-bit data available in the HL pair, that will be directly copied into the stack pointer content. That means now the data content in the HL pair will be the address that is pointed by the stack pointer. I hope you are getting this point. So this is the function of this SPHL. So this is a register addressing mode. We have used only the register for the operation. 1 number of machine cycles is required. 6 number of T states are required. None of the flags are modified here in this case also. So for all this instruction, none of the flags are modified. Next we have the EI. EI means it is the interrupt enable. It is the enable interrupt. when this instruction is executed, the interrupts are enabled. So this is very much simple. Okay, this is a one machine cycle instruction. 4 number of T states are required. None of the flags are modified. Okay, so this don't require any type of addressing mode. Addressing mode is required for when there is a data manipulation. Next we have disable interrupt. This is just the opposite. We need only one machine cycle and 4 number of T states. None of the flags are modified and need not to mention about the addressing mode. Here the function of this DI, that is the disable interrupt, meaning is that when this instruction is executed, the interrupts are disabled. Whatever be the interrupts arriving at the microprocessor, that interrupt will be disabled. Okay, next we have two complex instructions, that is the sim and the rim instruction. Okay, sim and the rim, these are the two opposite instructions. These instructions actually need dedicated videos for making you understand. So let me tell you in a brief form. Whenever we have this rim instruction, rim means it is the read interrupt mux. So what is the performance? So what is the operation? This instruction is used to read the status of the interrupts, that is the 7.5, 6.5 and 5.5. These are the status interrupts and the serial data input bits. So we will see in our upcoming videos in detail how the rim instruction is executed. So what will be the operation when we have the rim instruction? We need only one machine cycle, 4 number of T states. In the case of sim instruction, this is just the opposite. When this instruction is executed, the accumulator content is used to program the restart interrupt. In the previous case, that is in the case of rim instruction, we have read the interrupts in the case of rim, but in the case of sim means set interrupt max. Now we have to set the interrupt max. How we will set the interrupt max? Depending on the accumulator content. When this instruction is executed, the accumulator content is used to program the restart interrupt max. Max means we can say that we are supposed using a phase max, then we are covering the phase basically. So max means we are making some option. Okay, so we will see in detail about the sim and the rim instructions in our upcoming videos. Next we have the NOP. NOP. NOP means this is the no operation. Okay, N means no, OP means operation. Okay, no operation. Here we need only one machine cycle, 4 number of T states. None of the flags are modified. In previous case also, none of the flags are modified. In the case of no operation instruction, that is the NOP instruction, no operation is performed when the instruction is executed. The register and the flags are unaffected. That means they remain unaffected. So this was the last instruction in the case of stack input output and machine control group. Thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.